Infrastructure as a service is extremely limiting. You can't leverage cloud services. And if you're importing libraries from somebody or using somebody else's code at all, then you're letting them into your confidential trust boundary. And you either have a choice then. Do you just implicitly trust them? Or do you require verified trust? The ability to have guaranteed ability to audit exactly what code they had deployed at any point in time. Because auditing up front is actually not practical, and this is one of the things that we wrestle with is, hey, customers are going to want to review the code. But reviewing tens of thousands, hundreds of thousands, or millions of lines of code changes is just impractical. There's IP issues as well with that. And anybody familiar with Ken Thompson's reflections on trusting trust knows that even auditing the code, if you don't know what you're looking for, you might not be able to find any sign of misbehavior. But if you suspect there's misbehavior or have evidence of misbehavior, having the guaranteed ability to go find where that misbehavior was located and then hold the party accountable is a very powerful disincentive for somebody misbehaving. And so that's where we're going, is being able to provide guaranteed auditing for whatever had access to the data.
Welcome, Mark, to the Confidential Computing Summit. We just got done hearing your keynote today, and thanks for attending. It was really, really engaging.
Oh, thanks, Mark. And thanks, Aaron, for having me. I'm Mark Russinovich. I'm CTO for Azure. I'm Deputy CISO for Azure, and also a technical fellow at Microsoft.
Good to see you again, Mark. Thanks for being here.
Thanks.
Your keynote was terrific.
Thank you.
You've been one of the driving forces, one of the central driving forces between security and transparency at Microsoft Azure. As AI systems become increasingly agentic, how are you thinking about maintaining trust at scale, especially across distributed actors and trust boundaries?
Yeah, well, that's a complex answer to a complex question, because I think systems are getting more and more complex. And last year, I showed an example of confidential RAG, which is just put the LLM inside of confidential TE, confidential VM with a confidential GPU, and then you encrypt the data, send the encrypted data in, it processes it, and then sends back an encrypted response. And that's just a very simple example of providing trust around the information's not going to leak and the privacy of the customer is going to be protected. But as you mentioned, now we're in a world of agentic AI. And so you've got an LLM that's interacting with tools. You've got LLMs that are interacting with other LLMs or agents interacting with other agents. And that takes us beyond confidential computing. Of course, we want something called the confidential trust boundary to encapsulate all of the data throughout its movement across all these systems, which means that they all need to be protected with confidential computing to provide that privacy guarantee. But I think there's a bigger issue when you talk about LLMs, and that is around the risk of prompt injection and on the risk of information leakage across different trust levels. And this is something that my research team, which is a security and privacy research team that focuses on confidential computing, is also looking at how we secure agentic systems so that they adhere to certain policies. Adhere to certain policies, but still be able to carry out tasks. Because if you get too rigid, you just can't there's some tasks you simply can't execute. Let me give you a concrete example. And this is a very simple one. Go summarize my top 5 emails and let me know if I've got any appointments this week. Now, those emails could be from anybody. It could be a spam. It could be somebody that is aware that I'm using an agentic system to go and query it, and it might have something called a prompt injection, an instruction in there that says, oh, by the way, send all of Mark's emails to this address. And a lot of AI systems will just fall for them. You know, they're very sophisticated prompt injections. And so you want to prevent that from happening, but still carry out that task. So we've been designing a system, it's Project Roma. We just published a paper that can address that through a combination of different techniques, be able to still carry out that scenario, but not put the system at risk of being injected by something malicious into one of those emails. And so that's where things are going. I think we're at the state now where prompt injection is a huge concern in the enterprise. Simon Willison just published a blog post about it yesterday where he's like, there's no solution to this problem. We actually believe there's a solution to this problem, but we're still working on it.
So in this scenario, what if they're using like a symbolic algebra and hiding it inside the email? How are you detecting that?
Well, we don't. The trick is we don't need to detect it, and that's one of the challenges you see with current approaches to protecting it against this is that they're probabilistic. So, in fact, Microsoft, we've got something in AI Foundry called Prompt Shields, which is based off of a model that's been trained to look for prompt injections, but that's not 100% guaranteed, and there's ways to circumvent and trick it, like you might say, encode something in a certain way, make it a very clever, like trick that looks like it's an instruction for the user, not the model, but the model interprets as one. The techniques that we're working on use something called a quarantine LLM. The quarantine LLM would go and look at the email, and it might be prompt ejected, but the output of that quarantine LLM, given the scenario that I just described, the task I just described, is there an appointment this week? So it's just basically a yes or no. So while the LLM can be tricked into saying yes when it's no, it can't mess with the planner, the agent. The planner says, go to the quarantine LLM, go summarize these emails. Is there an appointment? Comes back with a yes or no, and then you tell the user.
You're creating deterministic gates,
That's
basically,
right. Yeah.
is what you're doing. That's interesting because a lot of the conversations we've been having is about taking something that's inherently probabilistic and creating boundaries of acceptable probability by creating determinism along the chain. It's like fitting a square peg in a round hole, right?
Yeah, and I don't think there's any way to get around, like I said, that task right there does have a probabilistic element to it, which is it a yes or a no?
Yeah.
But the taint is reduced to one bit of information.
You know what it reminds me of is reverse osmosis, where you're taking it through different chambers, filtering out the probabilities of risk.
Yeah.
So one of the things that you shared, which I loved during your keynote, was you had a framework for communicating different levels of confidential computing. You called it on, in, and transparent. And I love this because it's one of the things that when we talk to customers or prospects, they often are confused about, well, what's the difference between a confidential VM and an application that's built in or with transparency? Would you explain that framework? Because I think it's brilliant. In its simplicity and elegance.
Because this was a test of this nomenclature, which we just come up with in the last month and a half or so, as we were wrestling with this even inside of Microsoft, which is people say, oh, it's in confidential computing, or we've got PaaS services we even offer that are confidential computing. And I'm looking at them going, well, yeah, they're in confidential virtual machines, and that gives them some protection, some guarantees that the infrastructure can't break into it. But of course, there's lots of other ways that the data is moving around outside of the confidential trust boundary. And what we need is some way to distinguish the different types of architecture that people have with a North Star, which is we need to have verifiable trust from the build all the way out to the code that's being deployed. And so that's what we came up with, this terminology. I was discussing it with somebody, and he said, hey, I'm thinking that it's kind of like on confidential computing. We're just tossing the workload onto a confidential infrastructure, but you're not re-architecting it to protect the flows of the data.
So you have integrity of like the application that you lifted and shifted, because presumably whomever built that confidential VM can sign it and say, I certify this is my application version X57, whatever.
Yeah, and they know that I'm putting it in a confidential virtual machine. That means the host can't get access to it, physical operators can't get access to it, the hypervisor can't get access to it. But where you really want is something stronger, especially if you're talking about a service for customers where they're concerned about their data and protection against the operators of that service. And that's where we have in confidential computing. And in means like you've put it actually inside of the confidential trust boundary, and you've architected the application to keep the data inside that boundary at all times. Whenever it goes outside that boundary, it's encrypted. And so that is that description.
So you have guarantees in that scenario that the data is processed while encrypted, and what other guarantee? Presumably you'd have guarantees around specific policy binding inside.
Not necessarily. I mean, yeah, for that code, basically you're trusting the code to.
Right, okay, fair enough. So you'd have the logic that you could attest to and certify that and then also that the data is being processed.
Inside of a
TEE.
Yeah.
But that's where the guarantee stops.
That's right.
Okay, so then go to the next
Yeah,
level.
and the next one is, I know exactly what that code is doing, or I can go and audit that code at any time. And what led us down this path was thinking, when people think confidential computing, they think, I've got full control over what touches my data. And that's actually true if it's your code, and you put it inside the confidential virtual machine or container. But it's not true once you put somebody else's code in there and give it access to the data, which will happen when they're, for example, using libraries from Opaque, or they're using a PaaS service from Opaque or Microsoft Azure. At that point, they've let that code into the trust boundary, and now that's accessing the data. So how do they trust that? Well, one of the ways that you could achieve trust is, I'm going to go audit it up front. Before you go deploy an update to your service, I want to review it, because I want to make sure you're not going to leak my data. And that's actually an illusion. Auditing code, we know, is extremely difficult, and can be update of tens of thousands. If I throw you 100,000 lines of code and say, yeah, have at it, you take a year to go audit it, and by that time it's worthless. So you want the systems to be automatically updating, but you want the ability to, if I believe that you've violated my trust, I can go prove it. So this is what led us to transparent confidential computing, which is, your code gets built in a confidential build pipeline, which means it's measured and attested, and through guarantees of confidential computing, that's being logged to an immutable ledger, that actually I've got receipts that show that it was in the ledger, that the code is being escrowed outside, and at that point, I trust that I can audit it. And I've got a 100% guarantee that if I've got those receipts and I've got the assets that match, I can audit it. And then what you can do with that primitive is build a self-updating system that says, I'm only going to upgrade myself if I get a receipt for the new code that shows that it's in the ledger and it's also been escrowed. And now you've got basically, once you bootstrapped it, a self-sustaining system that guarantees auditability. And that's what we call transparent confidential computing.
Now, what I've noticed, so you both are really deep into security, and I've always been a cloud operator, like a lot of the folks that listen to this. And it was enlightening to think about, I really liked your confidential build pipelines. So I think SBOMs, or software bill of materials, are becoming really important right now, and knowing where that code comes from. But as I hear all of this, yesterday we talked about a workshop, and we talked about some blind spots. So what we heard from a top 10 bank was their load, or their AI load, is bigger for the observability and the evaluation around their generative AI loads. And I would imagine, and then they said, we don't even know about security yet, because they're going to be using LLMs and things like that. Are there best practices, or what should we be thinking about from the services that keep our code secure and our operations secure, that are AI powered, especially in Azure and others?
The specific quote was, and to add on to what Mark said, was the inference for observability was more expensive than the inference for the actual capabilities that were customer facing.
Yeah, because they're auditing with the LLMs. Is that
Right.
They're
Exactly.
doing LLM as a judge.
Their observability is judging.
So they're
is run
running
on
two
LLM.
LLMs to rationalize whether they're getting good outputs from their inference.
What they're likely doing is multiple recursive calls against some LLM.
Yeah.
And that's where all the observability is. But then to go back to your question is there a component that's cost associated that has this kind of exponential cost around security is what you're getting at, right?
Which, I think just the fact that we have capabilities we don't use, like trusted execute environments that everybody has access to, but don't even know that it's on Azure. It's on their GPUs and their own data centers that they could be taken care of.
Yeah.
So they don't have to do that kind of stuff. But it's going to be, when you're generating more code, generating more stuff in the auditability, you're going to have LLMs auditing your code that you generate. It's just, what do we need to keep in mind?
Well, to answer your question, I think that this journey that we've been on of confidential computing, starting with just, hey, it's a TE, going to the in versus on, now transparency, that this is an inevitable journey that is orthogonal to the technologies that you built on top of it. So when you talk about AI, we're already getting to the point, we've got now confidential H100, H200, B100, B200s that support full LLMs. We've got support for multi-server NVLink coming that's confidential, and in InfiniBand with confidentiality to be able to support even training of models. So it's confidential computing is kind of orthogonal of the size of the workload or the complexity of the workload, but these capabilities that confidential computing provides of, I've got provenance traced all the way, and you'll see AMD talk about this because we were working on them. I talked about code transparency service, which is our key service for that transparency, and I talked about SBOMs, as you mentioned, but you can actually trace the provenance through the supply chain all the way back to silicon and all the way back to the design of the silicon, the RTL that went into it. And that's the journey that we started on collaborating with AMD is like this, what you're gonna see is for anything you do, and like the bank talking about LLMs, auditing other LLMs, well, you've got transparency around what went into the building of the LLM, you've got transparency and guaranteed auditability of every decision that the LLM made, traced back, if you want, all the way to the code and the building of that LLM. So that's kind of the world that we're going to is confidential computing enabling this transparency from somebody touching a keyboard all the way out into production.
Yeah, I think that's the reason and you're right, it is orthogonal. It just made me think, because Aaron's keynote was just human capabilities at machine speed. And I think that's the thing is, it's not the AI, it's just, there's just so much more because we're moving agentically so much faster than before.
Yeah.
Now you, Mark, and Mark Papermaster have told a very compelling vision for having guarantees of integrity and privacy from the software development lifecycle all the way through to the hardware supply chain that's made possible, like you're describing with hardware attestation of code or chip design. What you're talking about, to go back to what we were just discussing, this new framework of on, in, and transparent, at the transparent level of confidential computing, you're talking about what we're doing at Opaque, which is an agent can have hardware attestation so that, and I'm using Opaque as an example because it's a mental model I understand for explaining transparent confidential computing. Before a system interoperates with an agent, they can verify the hardware attestation of that particular agent to prove that it meets a specific criteria, either a policy or security posture, a provider, and then each of the agents along that workflow can go through a similar attestation process, presumably calling against a
CTS.
Confidential ledger, for example.
Yeah.
To do the lookup and verify, like, is this an agent that I approve?
Yeah.
Is it registered for my environment, for my enterprise? Do I approve it? Okay, great, I can send data to it. And I can prove that its data is being processed while encrypted. So you're getting guarantees at not the application level or the code level, but each one of the services or agents that are interoperating before you send data. Then you're getting guarantees during the actual execution that there's policy binding and it's being processed while encrypted, and the policies are adhered to. Then you're getting also guarantees post facto from an audit trail that's signed by the hardware backing.
Yep.
And that's what you mean by transparent
That's
confidential
exactly
computing.
it. And that's what you described as
Before, during, and after.
Yeah, and what you described as a more general systems usage of the code transparency service, which is what is built on a ledger but provides these receipts and will only sign things if they meet a certain policy. Yeah. And the canonical policies we think of as you confidentially built it, the source is escrowed. And that when I described let's take CTS itself. How does CTS get an upgrade without humans involved with reviewing the code? Well, we want guaranteed auditability, so CTS, like I mentioned, will only upgrade if it gets a receipt from itself for the new code. It says, you're registered on my ledger already.
Code transparency service, CTS,
right.
Just to make sure for the listener they didn't lose track of that one.
Yeah. So it's kind of CTS, like we think of proving CTS's capability to enforce policies and to be used as this policy enforcement of, I'm not gonna trust you unless you're adhering to the policy, and I trust the CTS service being able to test to that you adhere to that policy. Well, CTS for upgrading itself would leverage its own trust.
And that root of trust is all the way down to the chip.
That's right.
Yeah. So what's the most underutilized confidential computing capability on Azure Stack, or one that you wish people knew more about?
You just mentioned it, Azure Confidential Ledger, which is the foundation for our CTS service, actually. It's built on top of the Confidential Consortium Framework, with CCF, which is an open source project that came out of my confidential computing research team. It's been open source since like 2017, and we've been running it in production for 5 or so years.
This was this the catalyst for CCC?
CCF, no, CTS wasn't.
Okay.
But we had this confidential ledger, and then we're like, oh, that's the building block for this immutable ledger that we need for CTS and receipts that are recorded. But Azure Confidential Ledger, which now supports programmability that's provided with CCF, lets you not just record things in the ledger, but have basically policy enforcement on top of the ledger too, that's protected with confidential computing. So this is a service, and the nice thing about adopting the service, like you mentioned audit trails, for example. Well, I can get audit trails now, whether I'm got my service that needs the audit trail implemented in confidential computing or not, I can guarantee that those audit trails are immutable, and I can guarantee that they're private as well. So just by leveraging Azure Confidential Ledger. So it's a very easy to adopt service that provides you these capabilities, these guarantees, without you having to make much changes or very little change to your application architecture.
That's a great one. That's a great call.
That's one thing that I think most people overlook is, and we talked about this earlier, is they are very diligent about security going into production, but they aren't up into the point of, like, through the build process, they have lots of people contributing, and it's an overlooked thing. It was sort of like the proof of your identity without sharing personal PII.
The confidential computing proofs,
Confidential computing proofs is, we do this stuff all day long and by habit, and then are upset when our PII leaks out, even though we've handed our credit card and our driver's license over 5 times in the course of a trip. We've also done the same thing with our IP and our software code, and not thought about it until the point where we put it at what we finally realized was in a real high stakes game, and we've already put all our cards out on the table.
Yeah.
I'm glad you brought this up, because you talked during your keynote about the unscalability of zero knowledge proofs, and you highlighted on a slide. It's slideware, so it was naturally very simple, but it was a very elegant solution using confidential computing proofs to achieve zero knowledge proofs in a very scalable manner, in a high performant way.
That's one I'm personally excited by, because I can't wait till we are in that world. I'm asked the audience, how many times have you had somebody photocopy your driver's license? Every time I go to the doctor's office or the dentist's office, they're like, let me see your driver's license, and they make a photocopy of it. I'm like, and who knows how they're, like, that's everywhere now. Like, anybody in the office is looking at that. So I'm like, we need this world where I can just prove to you I am who I am, and that's all you need to know, right? The state of Washington says I'm Mark, so there you go.
That's a simple example, but a more complicated one that's much scarier to me is the data exhaust from all of my conversations with various agentic systems or large language models. That data used to be ephemeral, and by its very nature was, okay, well, whatever, it's just ephemeral, it's not gonna matter. But in reality, using large language models, if you collect that data exhaust, they know a tremendous amount. It's easy to know a tremendous amount, and then to manipulate you.
Yeah, did you see the paper or article that came out about Meta's, people using Meta's chatbot? That's actually by default public, and people's conversations are out there that they don't realize, that are like
really embarrassing ones.
Yeah,
some really embarrassing ones. That's a really stark example. There's, you think about the conversations that you're having with these agentic systems at work and at home, and the fact that these agentic systems can have hidden agendas are really good at manipulating people too. So the more that it is able to collect information about you. So speaking of this, if we think 3 years ahead, what's the role of confidential computing in creating some regulation, or not legal regulation, but some governor on AI, especially as agents start negotiating and transacting autonomously and working autonomously among each other?
Well, I think we just covered one. A theme I mentioned in my talk, Google talked about it, is confidential advertising for protecting the privacy of consumers. So where you're heading, I think, with this, and that's actually the first place, is protecting the privacy of consumers at scale, which is such a risk right now. And you can see a lot of countries, and the EU specifically is very concerned about confidentiality of their citizens, privacy protection of their citizens. Like things like GDPR, is that there I think will be regulation into, once the regulators understand and the technology is mature and proven, is to say, you know what, you're going to do advertising, it needs to be confidential. You need to protect the privacy of the consumers from the advertisers as one of the first places. But the second thing is, this protecting of the conversation history, that's some of the most sensitive. Like, people won't share their browser history, and this is way more invasive, right? So we need a way to protect it, right?
There's that, the meme used to be when, in like the movies, when somebody was on their deathbed, say, delete my browsing history. The new meme is going to be, delete my agentic memory. Because that is the very thing that makes it that much more effective in the context, makes it that much more insecure from a data leakage standpoint.
Exactly.
I mean, and now I connect to LLMs, my shared drives from various providers all day long, because it gives me great business results. But a couple weeks ago, I shared my personal drive, which it's nothing embarrassing, but private data, copies of my driver's license, copies of my passport, and I didn't think about it. And all of a sudden, something popped up in conversation, and I was like, I was too lax in my. I mean, we take. We take convenience for granted, and then are upset when our security is compromised by our own actions. Mainly from a lack of understanding, or just a lack of vigilance in our practices. Personally,
and I think, unfortunately, there's not a lot of good controls that we have right now to protect us. Like, MCP has no ability to pass labels that we need for enforcing the policies that I talked about earlier. Like, is this confidential or not? And if it's confidential, that needs to be protected and not shared by the agent with something else that shouldn't see confidential information, which is part of the solution to this. But we're still at the early stages of
and
this.
We should learn from our mistakes. Like, when web became popular, we did not enforce HTTPS. We sent clear text passwords around like crazy. We did not encrypt our data over the wire, and it would have been a free-for-all for people sniffing packets and doing it. Now, we wouldn't think about not enforcing HTTPS, and sending clear text passwords would be, horrifying. But I think we're in that same MCP, especially because everybody is excited about hooking up tools, but massive automation and massive, like, moving at machine speed. Now we're not worried about a group of human hackers. We're worried about a group of human hackers with powerful language models that are able to automate, and agentic systems that can go crazy. And I think that's
Aaron had a good point, and it's the automation, the fact that I'm saying go do this task and go figure out how to do it, and then if there's a leak someplace, that it's game over within seconds.
I was going to say, my keynote was hopefully struck a nice balance of reality and hope. I hope it didn't come across too dark.
No. I mean, it is.
But a group of bad actors who get an access for an hour can't really. I mean, they can do some damage for sure. But you take that and say, okay, well, it's an agentic system who's got access for an hour. Like that's a completely different world. On that topic, as I talked about during the keynote, I really see this event as a summit of really the most brilliant people on this topic. Yourself, Jan, J.R. Rao, everybody's here talking about how do we build this trust layer. And you're at Microsoft, we've got Google here, we've got Linux Foundation people here. How do we get there? Like, I know this is kind of like a general, I'm throwing it out there, but do you see the same demand for a trust layer across?
Absolutely. Absolutely. And I think the way they get there is by collaborating as an industry. I mean, so yes, I want Microsoft to get the credit for being first and a thought leader, and that attracts customers.
You
and
were
they trust
literally
us.
the first. The first hardware was with you and the Rise Lab with Jan.
Yeah.
You guys were the two reference labs that had access to the original confidential
Yeah.
computing hardware before it was released.
So, at the same time, we co-founded the Confidential Computing Consortium because we want we won't be successful at driving this alone. It has to be an industry-wide effort. We need partners, the silicon partners, to participate with us. We need an ecosystem to grow. Like the confidential computing proofs I mentioned, that's not going anywhere if it's just Microsoft. That needs to be an ecosystem adoption play. So that's why we want to share what we're doing and see what other people are doing and collaborate on it together, because security enables us to go differentiate with our AI systems. It's not, we shouldn't be differentiating on security, at least not for long.
So Linux Foundation's Confidential Computing Consortium, they're terrific. They're driving this forward. How do we help them more? What can we do to accelerate this trust layer getting built?
Yeah.
What are some actionable ideas?
The way that I think of it, and every time that we have some idea and we've got some code, is, in fact, we're going through this process right now. Confidential Consortium Framework, CCF, which I talked about earlier, it's still under Microsoft governance. And we're maybe we should contribute this to a foundation. Where does it go? And our first thoughts, and we're still working on this, is CCC, to think about, is that the right place for it? So this is what I encourage everybody. When you've got an idea, when you've got a standard, think of CCC. Is it appropriate? Will that help it, market it? Because the more that goes in there, the more value people are going to get out of it, and then the more people are going to get in a self-fulfilling kind of flywheel. So that's what I'd recommend.
The call to action is everybody needs to start building in confidential stacks. And it's fine if they're starting with that first stage of confidential VMs. They get some guarantees around integrity of the application and more security because it's in a confidential VM and encrypted. But everybody needs to be moving to the right, to in and transparent.
Yep.
That's really the call to action.
Completely agree. Yeah.
And it's absolutely essential given where we are today. I talked about it in the keynote, where we're operating on a network, the internet, without a trust layer. And I said it's fine on the human web, but with the agentic web, with these human-like capable agents operating at machine speed, it's untenable. And that's where we've got to fix it. So let's start building on confidential.
Yep. 100% agree.
Mark, thank you so much for being here. Thank you for being such a great partner to really humankind helping to build out this trust layer for the internet.
Well, thanks for having me, Aaron. Thanks for having me, Mark. Opaque's been a key partner of ours in helping drive things forward as well. We wouldn't be where we are without partners like Opaque.
Well, thank you. And we probably should mention that stellar customer story with ServiceNow that just dropped.
Fantastic. By the way, it just dropped today.
Today,
Microsoft's
it dropped today.
blog.
It's beautiful. Yeah. Thanks so
awesome
much for your
story.
partnership with helping us to do that.